this is the last of the 7 questions, at least the order I've done it. I got all the other ones in, so be able to basically get partial derivatives in this case over here. Okay, so question 10. We're given a cost function, weekly cost in dollars to manufacture X cars and Y trucks. So X is cars, Y is trucks. Okay, compute the marginal cost of manufacturing cars at a production level of 10 cars and 20 trucks. So what they're asking for is the first derivative with respect to X, right? Because X is cars. There we go. Okay, so we want the derivative with respect to X of XY. We're going to plug in 10 cars and 20 trucks, so we'll actually get a value, right? But we'll do the first part, derivative of 240,000, that's a constant, that derivative is 0. Taking the derivative with respect to X, 6,000X, that becomes just 6,000. X becomes 1. 4,000Y, Y is a constant, so that becomes 0. Now this last part, we take the derivative of X, so that's going to be minus 20Y. So notice the marginal, that's the marginal. We can then plug in 10 and 20. I'll do that as the next step. There's no place to put the X value, so we just get 6,000 minus 20 times 20. So it's really dependent on trucks. So there's 6,000 minus 400. 2 times 2 is 4. A couple zeros. So our answer is going to be 5,600. That's the marginal cost at this production level. So that this would be the cost to produce an 11th car. Okay, that's what that means. To produce an 11th car would cost us 5,600. Second question, compute the marginal cost for manufacturing trucks. So that's going to be a partial with respect to Y at a production level of 10 and 20. Okay, so C, partial with respect to Y of 10, 20. We'll probably see the same thing. It doesn't really matter the trucks, it matters more the cars. So the derivative, come back to the original function, 2400, its derivative is 0. 6,000x, x is a constant, so that derivative is 0. 4,000y, that's the first part that remains. Derivative of y is 1, so the 1 times 4,000. And then a minus 20xy, so the derivative of y is 1, so that's going to be minus 20x. That's interesting. So producing 10 cars and 20 trucks, the cost to produce a 21st truck, our marginal profit, is dependent upon this 10 going in for the 20. So I'll just do it this way. I got it here. Maybe I should have done it up there. Minus 20 times 10, 20, not 2. That's going to give us minus 200. 4,000 minus 200 is 3,800. It's kind of strange. I would think a truck would cost more to make, but maybe not. Maybe it's more basic. We don't know all this stuff. But anyway, so just to kind of put it out here, the 21st truck would cost $3,800 to produce. The 11th car would cost 5,600. Okay, so that's a marginal cost. So understand that the marginal is the cost to produce. One more, and it comes from taking the derivative, the first derivative. All right, thank you.